Bismillahirrahmanirrahim. Hello everyone. Today I'm going to present example 6.11. Consider the following function. You are given a piecewise ft equal to t and 2, and if ft is t for this domain 0 to 2 and ft equal to 2 for t from 2 to 4, and you have another equation here, ft equal to ft plus 4. So this equation indicates periodic function. Question A, sketch the above periodic function over negative 8. Okay, so to sketch, remember you have to draw two straight line, horizontal and vertical line, and put the labeling. On the x-axis we put this as t. Why? Because it depends on our function. Now you are given ft, means your x-axis or horizontal axis is t, while the y-axis here is ft. After you put the labeling, you need to put the scales. Here I put 2, 4, 6, 8. Why? Because I refer to the given domain 0 to 2, so we know that the increment is in 2 units. You can put the scales like this, and then it's time to plot the graph. Okay, so this is piecewise graph, ft equal to t. What is the shape of the graph? Remember, if we change ft to y and we are using x, this is just a line y equal to x, so we know that is a straight line, right? So for the straight line, we just can substitute any value, any two values. We plot the coordinates, and then we can connect the coordinates, the two coordinates, by a straight line. So here I choose the first value is 0. Why? Because I refer to the lower limit of this. Lower bound is 0, so I substitute t equal to 0. And since the function is ft equal to t, so ft equal to 0. So the first coordinate to be plotted is 0, 0. So in the graph, you have to plot 0, 0. It is located at the origin. This is 0, t and 0, ft. Okay, and then for the upper bound, we substitute 2 when t equal to 2, ft equal to t, and since t is 2, so means that your ft equal to 2. So the next coordinate that we obtain from this substitution is 2, 2. Then you plot on the graph 2, 2. Okay, remember that we need a straight line, so you just take a ruler and make a straight line to connect both points. Okay, then look at another domain from 2 to 4, ft equal to 2, so it's just a horizontal line representing 2 along this region. So for one cycle, you get this curve, right? This is the 1 unit cycle. Okay, and then since you have to sketch over -8 to 8, you have to repeat the same pattern after 4 units. Why I need this for? Because it is given 4, and also we know that the period or the distance traveled by this one cycle is 4. So you just to repeat the pattern like this on the right hand side and the left hand side. So overall, you have 4 cycles shown on the graph. Okay. Next is to find its Fourier series. We know that in finding Fourier series, you have to show the calculation of A0, AN, and BN. And to calculate that, we need information. Okay, we need a certain information, which is the period. Okay, so here we label the period as capital T equal to 4. The 4 value here you can take from the given periodic statement 4, or you can calculate the distance of 1 unit cycle. This is 4. So that is consistent for here and for here. And then we need another value, which is omega. If you forget the formula for omega, you can refer to the math formula book on the Fourier series formula, right? Omega is 2 pi over t. Here you just need to replace the value of t. T is 4, so we simplify, we get pi over 2. Okay, and also from the graph you can define whether it is odd or even function, because somehow it will help us in doing integration. So just let's identify whether it is even or odd. Okay, if it is even, the graph must be symmetric along y-axis. So imagine you have a mirror here. Okay, is the object on the right is the same reflection on the left? No, it is not. So f is not even. Okay, and another thing that we must identify is the odd. If it's odd, the graph is symmetric about the origin. Okay, the graph. But here, if we put a mirror, this line should be reflected downward, negative of that. But it is not for this case, so we conclude that the function is not odd as well. So ft is neither even nor odd. So we cannot use the properties of even and odd for this case. But it's okay. Next, we proceed to find a naught, because in the, to fulfill Fourier series, you have to calculate a naught. Okay, by using the exact formula from the math formula book, a naught is 2 over t integral dd plus t ft dt. Okay, this is directly taken from the math formula book. And then it's time to do the substitution. 2 over 4, since t is replaced by 4. And then for the integral limit, why we have 0, 4? Remember, the integral limits must have the similar distance as a period. Means that the distance from the lower bound to upper bound must be equal to 1 period. So here, you just need to look at the given problem here, ft. ft is from 0 to 4. Okay, but from 0 to 4, you will have different curves. But for the integral limit, put 0 to 4, indicating the period. Okay, so that's why we have 0 to 4. And then ft dt. Okay, the coefficient 2 over 4 can be simplified into 1 over 2. And then this integral 0 to 4, since it consists of 2 different curves, you have to separate the integral limit. Means that this integral can be separated into 2 by putting the integral limit from 0 to 2 and 2 to 4. So if you add this together, you will get 0 to 4, similar as the original. But since this is piecewise function, you must do like this. Okay, you must separate the integral limit. All right. Okay, now for 0 to 2 domain, okay, 0 to 2, the function here is t, so we will replace by t. And for 2 to 4, the function equal to 2. You can refer to your original function given here. 0 to 2, the function is t. 2 to 4, the function is 2. Okay, then after we replace, we get this integral, right? Then after that, you can evaluate this integral. Okay, you can use your calculator. Okay, just put the integral sign in your calculator. In the version of class Swiss, we have to represent it as x symbol in the calculator, so it becomes x dx 0 to, like this. Okay, this is the symbol displayed on your calculator, and then this equal to 2. And for this case, you integrate, you get 4, and you have to add them together because we have a plus sign here. And then we simplify, we get a naught equal to 3. Okay, and then the next thing is to find an. An, the formula is this: 2 over t d plus t d ft cos nwt dt. So now you have to replace the value of period capital T here, and also you need the value of omega. We have calculated these two parameters earlier, so we just take it, t equal to 4 and omega is w over 2. Then we replace the value of period here, and omega is replaced by pi over 2. So this is what you have, alright? And then again, for this piecewise function, the integral limit, is from 0 to 4. The next step is to separate this integral from 0 to 2 and 2 to 4. And then we put the function, okay? From 0 to 2, ft is t, and from 2 to 4, ft is 2. Then we get this, okay? So to get the value, okay, you can perform the integration theoretically, means you have to integrate this one. Since they appear twice, which is in the as a polynomial here, and t is appear in the cos. So basically you need to apply a integration by parts technique, okay, or you can use tabular method. So for this class, I will show you how to use your calculator, okay. So I will show you in the next video.